Good afternoon. My name's Mike Hewson, and this is the Mathematics Bytes channel. The purpose of this channel is to present mathematics in easy to digest bytes. So the videos aren't going to be going for too long, and they're going to be aimed at the beginning to intermediate student. I hope this is a relaxed format where the rigor police are not on duty. Today's topic is powerful logarithms. You may recall our last video where I introduced the basic idea of converting error-prone and tedious multiplication operations into reliable and simpler addition of logarithms. You may recall that we have John Napier to thank for this technology. Also recall the value of the natural logarithm base, which is denoted with the lowercase e and has the approximate value of 2.71828. And I remind you again, it is a transcendental number. Let's write down a number that's just at the top of my head. Yes, you've guessed it, that's good old pi, or at least an approximation thereof. It's another transcendental number. And like any number, we can take its natural logarithm. And evaluate that via a lookup table to 4 decimal places after the decimal point, giving a value of 1.1447. Suppose now I was to multiply that logarithm by a factor of 3. Giving the result 3.4341. As before, I can now take the anti-logarithm and see what number I get. Lo and behold, it is 31.0035. You may wish to pause the video at this point to think, what is it that we did when we multiplied the logarithm by 3? The answer is that we have cubed the number. This is the cube of pi, 31.0035. If you like, I could also represent this operation by adding the logarithm 3 times. Which gives the same result. I could then, of course, take the anti-logarithm and get the same number. Let's try another example. We'll use the number pi as before and take its logarithm as before, but this time we will divide the logarithm by 2. (0.57235), and as always we will now take the anti-logarithm of this number to give 1.772. Pause the video if you like and try to think of what we have done by dividing the logarithm by a factor of 2. We have taken the square root of pi. So what we have discovered, therefore, is multiplication of the logarithm raises that number to a power, and dividing the logarithm by a number takes a particular root. Let's now summarise what we have learnt thus far. The logarithm of a product is the sum of the logarithms. The logarithm of a quotient is the difference between the logarithms. The logarithm of a number to a particular power, p, is just the logarithm of the number multiplied by p. And finally, to get the pth root of a number, we divide the logarithm by p. See if you can commit these rules to memory. It will serve you well. Now we could evaluate some more complicated expressions, but they would simply break down into simpler steps involving one of these 4 operations. It is hard to understate the impact of logarithms on the scientific world. That's enough logarithm work for today. This video was produced with the help of the Movavi Video Suite, Microsoft Windows 7, the Paint program, and of course has been hosted by YouTube. Good afternoon.